Welcome to the Deep Dive. Today we are looking at numbers that really redefine the meaning of scale and technology. We're talking about this sheer, almost mind-bending flow of capital into artificial intelligence infrastructure right now.
Yeah.
It signals a really intense new phase of the tech revolution, one that seems totally defined by who can actually secure compute capacity.
It's an unprecedented financial moment, truly. We seem to have moved beyond just, developing cool new models.
Right.
We've very rapidly entered an era of, well, infrastructure warfare, essentially. The deals we're seeing are just shattering previous records for tech contracts. It's like chips, data center space, reliable power. They're being treated like the most critical strategic resources on the planet.
So our mission today is to unpack this shift for you. We're analyzing sources that detail both the financial frenzy, these huge, staggering mega deals worth hundreds of billions, and at the same time, we're tracking the technical direction. We've got sources outlining 5 key AI trends identified by industry leaders that are really defining innovation and, crucially, the path to getting a positive return on investment looking ahead to 2025.
And the central insight here, I think, is realizing that access to computation, it's become the single biggest barrier to growth for these companies. They're locking in capacity years ahead of time.
Years. Wow.
Yeah, years. And that's what's fueling these record-shattering cloud contracts we're hearing about. But we also need to understand where all that compute is going. The most sophisticated AI models, they're finding their biggest untapped potential not just in generating text or images.
Which was the early focus.
Exactly. But now it's in advanced reasoning and autonomous action, particularly within the high-value enterprise space.
Okay, let's dive into this monumental shift then, starting with the capital, because this feels like the new baseline for tech spending. Let's call this Section 1. The AI infrastructure arms race securing compute at any cost.
So the demand side of this equation, it really started accelerating the moment large language models, like ChatGPT, hit the mainstream back in late 2022.
Right, that was the inflection point.
Definitely. Since then, investment in the foundational systems, the stuff that actually powers AI, has just surged dramatically. And a lot of this is now driven by large legacy enterprises. They're finally adopting AI, but they're demanding 3 specific things: optimized performance, demonstrable profitability, they want to see the ROI, and, of course, robust security from any AI solutions they integrate.
And the immediate problem, the really urgent thing driving all this massive spending, it's scarcity on the supply side, isn't it?
Absolutely. Demand for the most advanced chips, we're talking high-end GPUs mostly,
Right.
and the physical real estate you need for data centers, it just continues to dramatically outpace the ability of suppliers to deliver.
So you can't just order them when you need them.
That's exactly right. If you want to train the next generation models, you simply cannot wait for the chips to roll off the assembly line next quarter. Companies are being forced to commit capital, sometimes years in advance. They're essentially buying bandwidth that doesn't physically exist yet,
Wow.
just to guarantee they don't hit a wall tomorrow, to guarantee they aren't bottlenecked.
And this urgency, this need to secure capacity years out, it really defines the scale of what our sources are calling the Oracle mega deal portfolio. I mean, the most remarkable figure, the one that seems to have redefined the market, is that reported $300 billion cloud agreement between Oracle and OpenAI.
$300 billion.
Over about 5 years, reportedly.
Mm-hmm.
Our sources are pretty unambiguous. This is one of the largest technology contracts ever recorded. It signals a whole new era of infrastructure commitment.
And to really understand the sheer physics of this commitment, you have to look at the energy consumption involved. The sources note that securing this kind of capacity requires something like 4.5 gigawatts of continuous electricity.
4.5 gigawatts. That's a number that's, well, it's hard to visualize. How can we put that into context for people?
Okay, so to contextualize that for you, 4.5 gigawatts is roughly equivalent to the power consumption of 4 million U.S. homes.
4 million homes.
Yeah. We're talking about dedicating the power output of essentially a small city just to running and training AI models for a single client.
That's incredible.
And that energy commitment, it really highlights the unusual economics of this field. Unlike traditional software services where you might have high upfront development costs, but then the marginal cost of running it is pretty low.
Right. Software scales easily.
Exactly. AI is defined by heavy, consistent operational spending. You've got hardware depreciation, constant upgrades needed, electricity costs, massive cooling costs. It just keeps adding up.
I see the distinction there. So this $300 billion, it isn't just like a development budget to create the AI. It's mainly an operations budget, right? For guaranteeing the stability of the models once they're actually being used, the process they call inference.
Precisely. Every single time a consumer or an enterprise employee uses an AI tool, maybe for customer service or fraud detection or generating some content, that inference process requires significant compute power. And those costs accumulate, billions of times a day across the globe. So the Oracle deal fundamentally is about purchasing operational stability. It's ensuring OpenAI's growth is never limited by hardware availability.
But isn't relying so heavily on just one external provider like Oracle, even with a contract that huge, isn't that a massive single point of failure for a company like OpenAI? What do the sources say about that strategic risk, putting all those eggs in one very expensive basket?
That's a really critical question. And while, the public focus is obviously on the giant dollar amount, the strategic advantage of such a long-term contract is actually stability for both sides.
Okay.
For OpenAI, it absolutely guarantees supply in a market where supply is incredibly scarce. And for Oracle, well, the contract provides highly predictable recurring revenue over 5 years. That significantly de-risks the whole thing for investors and lenders who are funding the construction of all the necessary data centers.
I see.
In a way, the massive size of the deal itself acts as its own sort of security blanket. It locks both parties in.
Okay, that makes sense.
Yeah.
And OpenAI isn't the only one making these huge foundational infrastructure bets. We're also seeing reports about a potential Meta partnership emerging, advanced negotiations between Oracle and Meta for another multi-year cloud deal.
Yes, and the numbers there are also huge, potentially valued initially at $20 billion, but with sources suggesting that figure could grow as the discussions finalize.
$20 billion still sounds enormous, even next to $300 billion.
Oh, absolutely. And this potential Meta deal is profoundly significant. It really illustrates the intense pressure that even the largest, most historically self-sufficient tech giants are facing right now. It just underscores Meta's aggressive push to secure computing power immediately. They need it for training and deploying their Llama AI models and for rapidly expanding AI features across, Facebook, Instagram, WhatsApp, their whole ecosystem.
What's really revealing about Meta, though, is their history, isn't it?
Yeah.
Traditionally, they've been one of the most self-reliant players out there. They own and operate more than 20 massive proprietary data centers globally.
That's right. They built their empire on self-hosting.
For years, it was clearly cheaper and more efficient for them to do it themselves. So this potential external partnership with Oracle, possibly worth $20 billion or more, it speaks volumes about the urgency they must feel.
Exactly.
It suggests the speed required to catch up, or maybe just maintain a lead in AI development, is now outweighing their long-held strategy of saving costs through proprietary infrastructure.
Right.
They have to buy it now.
Precisely. They seem to be following the market mantra right now, which is spend whatever you must, but compute access is absolutely non-negotiable. And if we connect this to the broader competitive landscape, this spending isn't happening in a vacuum. It's an ecosystem-wide capital flood. It basically validates the entire sector's direction.
So give us the scale of that competitive spending, just to show the breadth of this capital flood. It's not just OpenAI and maybe Meta.
Oh, the numbers are relentless. You've got NVIDIA reportedly set to invest up to $100 billion in OpenAI, not just supplying chips, but actually taking a financial stake in their success.
$100 billion investment.
Yeah. Then there's CoreWeave. They're an NVIDIA-backed startup focusing on specialized cloud services for AI. They signed a staggering $6.3 billion initial order with NVIDIA for chips, and separately, an $11.9 billion 5-year contract with OpenAI to provide capacity.
Okay, so CoreWeave is buying from NVIDIA and selling capacity to OpenAI. It's a whole supply chain.
It's becoming a very complex supply chain. Then you have Nebius Group. They're going to provide Microsoft with $17.4 billion in GPU infrastructure capacity over 5 years.
$17 billion just for Microsoft's capacity from one provider.
And we can't overlook the significant investment Amazon pumped into Anthropic, OpenAI's competitor. That was a $4 billion commitment, doubling down on the developer of the Claude chatbot.
Right, Anthropic. So, yeah, the volume of capital being committed across the board is just breathtaking. It feels like it's establishing a completely new financial baseline for what it costs to be a serious player.
And what's fascinating here is that these multi-billion-dollar commitments, they're rapidly becoming the new standard. What seems exceptional today, like that $300 billion OpenAI deal, might soon be regarded as just, the average cost of entry for delivering foundational AI services at a truly global scale.
Wow.
This shift fundamentally reframes market expectations for technology companies, for their spending, their revenue, everything.
So how do you even finance infrastructure projects that scale like this? We're talking tens of billions, potentially hundreds of billions. Traditional venture capital or even corporate debt, that doesn't seem like it would cut it for these kinds of numbers.
No, it requires a pretty strategic shift in financing models. Private credit and project finance are becoming absolutely crucial here. They're stepping in where traditional lenders might be a bit hesitant given the sheer scale.
Why are they less hesitant?
Because these long-term contracts, like the Oracle OpenAI deal, they provide extremely predictable revenue streams over, say, 5 years. That predictability significantly de-risks the massive capital expenditure required upfront to build the data centers.
Okay.
It makes it much easier for banks and specialized investors to fund these huge data center projects, especially as they expand into new geographies looking for power and space places like Wyoming, Texas, New Mexico.
And if you want the ultimate example, maybe the peak example of this reframed market scale, you have to look at the reports about the Stargate data center project.
Yeah, Stargate is, well, it's the speculative pinnacle of this whole infrastructure arms race right now. It's reportedly a joint venture involving SoftBank, OpenAI, and Oracle. And the potential investment figures being floated could reach an absolutely astounding $500 billion just for AI infrastructure funding.
$500 billion for infrastructure funding. That single number, $500 billion, is truly staggering. It just marks infrastructure funding, not even the model development itself, as a new frontier of global technological competition.
It really does. It strongly suggests that the major players are realizing that the physical scarcity of land, of power, of advanced chips, it demands almost a wartime approach to resource acquisition. They're effectively building the equivalent of national infrastructure systems, but dedicated solely to AI.
Wow. Okay. That infrastructure arms race has clearly fundamentally altered the competitive landscape, and it seems no company has capitalized more dramatically on this shift than Oracle itself. Let's move to Section 2, Oracle's strategic pivot and ascent in the cloud market.
Oracle's transformation, yeah, it's been a remarkable piece of strategic execution. For decades, they were defined by their enterprise software, their database dominance.
The old guard, almost.
Kind of, but they have rapidly expanded their cloud infrastructure business, OCI, specifically to position themselves to compete directly with the original hyperscale leaders, AWS, Google Cloud, and Microsoft Azure, particularly in this AI niche.
And the market validation seems clear. Just on the news of that potential Meta deal we mentioned, Oracle stock jumped 4%. And it's gained something like a massive 85% year-to-date.
Yeah, the performance has been strong.
They're showing rapid expansion, too, reporting that their backlog, their future contracted revenue, swelled to an unprecedented $455 billion after signing 4 multi-billion-dollar cloud deals in just its fiscal first quarter. That includes those reported deals with OpenAI and also Elon Musk's XAI venture.
And what seems to be driving this ascent is Oracle's really shrewd competitive strategy. It's aimed squarely at the specialized needs of these heavy AI workloads. They're positioning OCI not really as a general-purpose competitor to AWS.
Like a head-to-head everywhere.
Not exactly. More as a specialized, often more cost-effective alternative that's focused on the specific, massive computational requirements of machine learning. And this focus, it's clearly attracted the leading, most demanding AI companies.
The cost-effectiveness argument is interesting, but their interoperability strategy, that seems almost counterintuitive to the typical cloud lock-in model we usually see. How does that work? Is Oracle intentionally sacrificing potential long-term lock-in just to grab immediate market share in the AI boom?
Well, that seems to be the crux of their genius right now, or at least their current strategy. Oracle's approach is highly pragmatic. They actually allow cloud customers who are primarily using Amazon, Alphabet, or Microsoft to run Oracle's OCI alongside their existing native services.
Okay.
They aren't forcing companies into an expensive, painful, full migration off AWS or Azure. Instead, they're offering a specialized, almost plug-and-play solution just for the most taxing AI tasks.
So if I'm a big enterprise and I'm running most of my business on AWS already, but I suddenly need this specialized OCI compute capacity for my new generative AI project, Oracle makes it relatively easy to integrate that piece without forcing me to pull my entire company off the familiar AWS platform I'm already using.
That's exactly it. And the results seem to validate this hybrid collaborative approach. The sources show a staggering surge in revenue from these kinds of partnerships, something like a more than 16-fold increase in just the first quarter alone.
16-fold.
Yeah. They seem to have correctly identified that the fastest way to gain significant market share in this hot AI segment is through collaboration, not necessarily demanding total platform dominance right away.
This willingness to collaborate at the infrastructure layer, it really marks a significant departure from the historical winner-take-all dynamics we often saw in the cloud market's earlier days.
It does.
We also saw some recent executive changes at Oracle that seem to emphasize just how centrally important AI is to their future strategy.
Yeah, the organizational alignment is a very strong indicator of their commitment. Safra Katz, who had been CEO for a long time, she transitioned to executive vice chair, more of a strategic oversight role.
Right.
And two new co-CEOs were named. Clay McGork, who was the president of Cloud Infrastructure, the OCI guy, and Mike Sicilia, who was president of Oracle Industries.
That seems like a very clear mandate. Promoting the infrastructure leader and the industry-specific solutions leader to co-CEO roles, it explicitly aims to boost Oracle's high-growth bets on AI, doesn't it?
Absolutely.
They're structuring the whole company around the pipeline of the two things that are growing fastest for them: cloud capacity, and then leveraging that capacity for specific enterprise problems.
And Wall Street analysts certainly seem convinced, for now anyway. They're maintaining a strong buy rating on Oracle stock, reflecting significant confidence in this specialized cloud strategy. It feels like the entire company has pivoted to serve this new, extremely compute-hungry AI market.
Okay, so the capital flood seems validated. Oracle has emerged as a major strategic player because of it, and access to compute capacity is clearly the name of the game right now. Now, let's pivot from the money, from the infrastructure to the strategic direction of AI innovation itself.
Yeah.
We move into Section 3, the 5 trends shaping AI innovation and ROI in 2025.
Right. These 5 trends, which were highlighted at recent industry conferences like the Morgan Stanley Technology, Media, and Telecom Conference, they collectively indicate a sort of market maturity setting in. Companies are no longer just focused on creating novel, sometimes experimental models.
The focus is shifting.
It is. They're now prioritizing optimized performance, demonstrable profitability, again, that ROI and robust security, specifically for their actual enterprise customers. It's becoming much more about making AI work reliably, safely, and profitably for the business bottom line.
Okay, let's start with trend 1 then. AI reasoning and custom silicon fuel demand for chips. We probably need to clearly define what AI reasoning means here, because that capability seems to be the strategic goal that's driving this monumental demand for all that hardware we just talked about.
Yeah, AI reasoning is definitely the next frontier. It goes beyond the basic AI tasks we're familiar with, like classifying images or summarizing text. Reasoning is the capability that allows AI models to handle complex, multi-step problem solving. It involves advanced learning, making autonomous decisions, especially in novel situations it hasn't seen before.
So it's moving the model from being just a sophisticated calculator or maybe a translator
Exactly.
into something that can genuinely contribute to strategic planning or complex decision-making.
That's the goal. And naturally, achieving that higher level of intelligence, it significantly increases the compute demand across all stages of the AI lifecycle.
All stages.
Yes. It requires exponentially more compute power for pre-training just to make the model massive and knowledgeable enough in the first place. Then for post-training, where it learns to follow complex instructions and align with human values, and especially for inference, the actual running of the model, because those complex reasoning tasks simply take more time and more computational cycles than generating a simple response.
So the models need to be exponentially bigger and smarter just to perform these complex reasoning tasks reliably.
That's right. Bigger and require more power to run each time. And this massive demand feeds directly into this debate around custom silicon. Customers, especially the big cloud providers and AI labs, are facing a crucial choice. Do you go specialized for speed and efficiency or stay general purpose for flexibility?
Explain that trade-off.
Well, the hardware choice is a really crucial strategic trade-off right now. Customers are debating between buying specially designed chips called application-specific integrated circuits, or ASICs. Right. These offer potentially higher energy efficiency and better performance, but only for extremely specific, repetitive AI tasks. Think of a dedicated neural network chip designed just for image recognition, for example.
Okay, optimized for one thing.
Exactly, versus relying on general-purpose GPUs, which offer much greater flexibility across a broad range of applications, but might be less optimized, less efficient for any single specific task.
And the sources suggested that the demand for ASICs The specialized chips might be linked to where AI physically operates in the future.
It is, yeah. Executives noted that ASIC demand is likely to accelerate significantly with the expected massive future adoption of edge AI.
Edge AI.
AI running directly on small local devices, think smartphones, cars, industrial sensors, cameras, rather than huge data centers. In those edge scenarios, power constraints and the need for dedicated real-time performance often outweigh the need for broad flexibility. So specialized, efficient ASICs become much more attractive.
Okay, that makes sense for edge devices. Now let's revisit this paradox of efficiency you mentioned earlier, Jevons paradox. It sounds counterintuitive. If we're creating more efficient AI chips, shouldn't that lead to lower overall energy demand in the long run?
It does sound counterintuitive, but Jevons paradox explains this phenomenon really well. Executives at these conferences pointed out that recent AI advancements that improve computing efficiency, making it cheaper, faster, less energy intensive per calculation,
Yeah.
those improvements will actually drive higher overall aggregate consumption and long-term demand for AI services.
So the argument is basically, because it becomes cheaper and easier to use AI for a specific task,
Yeah.
enterprises won't just use it less overall, they'll actually find ways to use it everywhere, driving total usage up.
Precisely. Think about it. If a bank can suddenly deploy a sophisticated fraud detection LLM across all 100 million of its daily transactions because the compute cost for each check dropped by, say, 50%, the total consumption of compute power and energy across the whole bank will dramatically increase, not decrease. And that, in turn, further expands the total addressable market for the entire AI ecosystem. Chips, cloud, software, everything. Efficiency drives utilization, which ultimately drives overall demand higher.
Okay, got it. Efficiency paradox.
Yeah.
Moving to trend 2. Hyperscalers see cloud migrations and AI workloads as revenue opportunities. So this is how the big established players, AWS, Google Cloud, Microsoft Azure, are structuring their business to capture all this demand we've just discussed.
Yeah, their core strategy fundamentally remains volume and integration. They want to convince enterprises to use as many integrated services across their entire software stack as possible. They're building out these expansive, often proprietary AI platforms on top of their existing cloud services.
And this requires massive investment from them, too.
Oh, absolutely. It requires robust capital expenditures, or CapEx. We're talking tens of billions of dollars annually for each of them spent on commercial cloud servers, networking gear, and constantly expanding their portfolio of AI offerings, particularly focusing on those advanced reasoning capabilities we just talked about.
But they can't just spend endlessly without a disciplined long-term strategy, can they? What are they doing to try and offset those massive upfront infrastructure costs?
They seem to be executing a kind of two-pronged strategy to manage costs. First, they're actively working to optimize compute performance internally by developing their own customizable chips. Think Google's TPUs or AWS's Inferentia and Trainium chips. These give them more control over performance and cost.
Okay, custom silicon in-house. What's the second prong?
Second, they are intensely focused on ensuring maximum long-term utilization of their physical assets, primarily their huge investments in land and the construction of data center sites.
So they're not just buying chips. They're strategically acquiring and developing land in places that can actually support the immense power and cooling demands of future AI, guaranteeing they have capacity at stable prices years down the line.
Exactly. They are locking down geographical real estate and securing long-term power purchase agreements, often years ahead of actual need. They view internal efficiency advancements, like better cooling systems or those specialized chips, as crucial because it helps reduce their operational costs per unit of compute.
Which lets them compete on price.
Well, it allows them to potentially lower prices slightly, or at least keep them competitive, which encourages more customers to migrate workloads and increase their AI utilization. And then, thanks to that Jevons paradox effect we discussed,
Right.
that increased utilization eventually increases their total revenue, even if the per unit cost is lower. It becomes a sort of self-perpetuating cycle. Optimized capital expenditure enables broader adoption, which drives higher overall revenue.
Okay, a virtuous cycle for them, if they get it right. Let's move to trend 3. LLMs see potential in AI reasoning for enterprises. We've established that the early use cases for large language models were often things like basic content generation, summarization, maybe simple classification. Where's the real prize now, especially for enterprise customers?
The biggest untapped potential, and certainly the area driving the most immediate and significant ROI today, seems to be squarely in applying sophisticated AI reasoning capabilities to proprietary enterprise data.
Internal data.
Yes. This moves the LLM from being just a simple administrative tool, maybe a chatbot, into potentially an active strategic partner, something capable of making nuanced recommendations based on deep internal context and data.
Can you give us some specific enterprise applications where this reasoning power is actually being adopted today, and what makes it a key differentiator compared to older software solutions?
Sure. So today, LLMs are already being widely used for things like enhanced customer support bots that can handle more complex queries, or for internal knowledge retrieval systems that can effectively answer complicated questions by synthesizing information from disparate internal documents.
Okay, better search and Q&A.
Right. They're also proving powerful for coding automation, helping developers write and debug code faster, and for generating marketing content. But the reasoning aspect is the key differentiator in more complex, high-value areas. Think about context-aware product recommendations that don't just look at past purchases, but also factor in current local inventory levels and real-time logistics constraints.
That's much more complex.
Exactly. Or strategic planning assistance tools that can simulate potential market shifts based on various inputs. Complex compliance checks against rapidly changing global regulations, that's a huge one. And perhaps most lucratively, finding deep process optimizations across complex manufacturing or logistics pipelines by analyzing vast amounts of operational data.
The sources also mentioned some pretty phenomenal productivity gains, particularly in the software engineering sector.
Yeah, the gains there are potentially enormous. One executive estimated that the effective output of a single software engineer has already risen by perhaps 10 times or even more, thanks to AI-powered coding assistance tools like GitHub Copilot and others.
Isn't that?
That was the estimate. And this isn't just about generating simple boilerplate code. It's about the AI identifying subtle bugs, suggesting complex architectural improvements, even writing test cases. Furthermore, the sources suggest the earliest industries expected to fully harness this kind of tailored AI for such massive productivity boosts include biotechnology,
Biotech how?
specifically for things like accelerating the analysis of data from clinical trials or helping navigate complex regulatory submissions, and also the legal sector for advanced AI-powered paralegal work. Imagine reviewing millions of pages of discovery documents for relevant clauses in minutes instead of weeks.
Wow. Okay, but security is always paramount, isn't it? Especially when you're potentially using AI to inform multi-million-dollar decisions in highly regulated fields like finance or biotech. If the AI makes a mistake or exhibits bias, the company absolutely needs to know why.
That is arguably the ultimate hurdle to widespread, deep enterprise adoption: auditability and trustworthiness. Security and governance are absolutely central, which is why some leading LLM companies are now actively researching and trying to commercialize something called mechanistic interpretability.
Mechanistic interpretability. That sounds complex. What is it?
It is complex. It's the crucial and very difficult effort to essentially reverse engineer the AI model to understand exactly why it reached a specific decision, prediction, or output. Which internal mechanisms, which neurons or parameters contributed most to that particular result.
So how does mechanistic interpretability actually provide the necessary trust for, say, a regulated industry? Give us a concrete example.
Okay, consider a financial services firm using an AI model to help with loan approvals. If the AI recommends denying a loan application, a human auditor or a regulator cannot simply trust the black box output, especially given fair lending laws.
Right. They need justification.
Exactly. Mechanistic interpretability, if achieved, would allow that bank auditor to trace the specific layers, the internal calculations, and the input data weights that most strongly contributed to that exact denial decision. This could provide the necessary proof of non-discrimination, showing the decision was based on valid financial factors, not prohibited ones. It aims to turn the black box into a more transparent, auditable process.
Making it explainable.
Essentially, yes. And this capability is absolutely vital for regulated industries like financial services, healthcare, insurance, to truly trust the AI's decisions in high-stakes, high-consequence environments.
Okay, so interpretability is key for trust. Next up, trend 4. Data companies zero in on evaluating AI. So once you have potentially some auditability, you then need to actually measure the efficacy and the ROI of these deployed AI systems, right?
Yes, this is the necessary next step in the maturity curve of enterprise AI adoption. With models being deployed more widely now, the focus for data companies is shifting. They're now building sophisticated tools specifically designed to help enterprises automate observability.
Observability. Define that.
Observability is essentially understanding a complex system's internal behavior and health by analyzing the data it generates: logs, metrics, traces. In the AI context, it means understanding how the model is performing in real time. And alongside observability, these companies are creating evaluation systems to continuously measure AI efficacy. Are the models actually doing what they're supposed to do? Are they accurate? Are they fast enough?
This sounds like a direct response to those massive productivity increases in coding we just discussed. If engineers can suddenly write code 10 times faster, the bottleneck inevitably shifts downstream, doesn't it?
That's exactly the insight captured in the sources. We have a quote that sums this up perfectly. Writing code has become much faster with AI, but now the value is in testing and understanding it and seeing if it works for the business.
Right. The value shifts to verification and validation.
Exactly. Data companies are shifting their focus. They're building AI engines that are designed specifically to help other companies understand crucial things about their deployed LLMs. Are they generating factually accurate output? Are they maintaining low latency for real-time user experiences? Are they delivering the correct business outcome? That's the true measure of ROI.
What kind of data points do you need to track for this kind of observability and evaluation? It sounds like more than just checking if the answer is right or wrong.
Oh, much more. You need to track data points far beyond just the final output. For instance, you absolutely need to monitor latency, especially for real-time applications like chatbots or recommendation engines. You need to track the cost per inference very carefully to manage those enormous compute budgets we talked about.
The cost.
And you need to continuously measure the semantic accuracy of the response, not just if the words generated are grammatically correct, but if the meaning and the application of that output are correct and beneficial for the specific business context. This kind of sophisticated evaluation requires really robust, unified data platforms underneath it all.
Which ties directly into what the sources call the data lakehouse revolution. Can you explain how combining the flexibility of a traditional data lake with the structure of a data warehouse is necessary for this modern AI evaluation?
Sure. Historically, enterprise data was often siloed. You had data lakes, which were great for storing massive amounts of raw, unstructured data, like very cheaply. Think of logs, sensor data, images, but they weren't great for structured analysis.
Okay.
Then you had data warehouses, which provided highly structured, clean, high-quality data, perfect for traditional business intelligence and analytics, but they were often expensive and less flexible for handling raw data types needed for AI training.
So two separate systems.
Often, yes. The data lakehouse trend is about creating unified platforms that try to combine the best of both worlds. The low-cost, massive storage capacity and flexibility of data lakes with the structure, governance, data management features, and query performance of data warehouses.
And why is this unification critical for AI?
It's absolutely critical because modern AI workflows need both. Models need to train on petabytes of raw, often unstructured data, which fits the lake paradigm, but the evaluation, the auditing, the interpretability we just discussed, trends 3 and 4, they require that data and the model's outputs to be perfectly clean, structured, and easily queryable, which fits the warehouse paradigm. The lakehouse aims to provide a single platform for the entire lifecycle.
And this often requires forging partnerships across the AI ecosystem, doesn't it? It's not just one company providing everything.
It really does seem to. Building these sophisticated lakehouse platforms, especially the layers for evaluation and observability, frequently involves creating best-of-breed AI services through strategic partnerships. You might see collaborations for highly analytical tasks like cybersecurity threat detection using AI or specialized compliance monitoring tools, or deep industry-specific solutions built on top of the core platform.
So no single company can realistically own all the necessary expertise.
It seems unlikely. The infrastructure, much like Oracle's cloud strategy we discussed earlier, increasingly relies on interoperability and partnership to deliver the full value proposition.
Okay. Finally, then, we reach Trend 5, which definitely feels like the most long-term, maybe even futuristic vision. Software companies set sights on agentic AI.
Yes, agentic AI represents a pretty fundamental shift, or at least a proposed shift in how we might interact with software in the future. It's generally defined as the creation of large, perhaps operating system-like platforms that can deploy multiple specialized AI agents. Yeah, think of them as autonomous software programs. These agents would be designed to make decisions, take actions in the digital or even physical world, and adapt to changing environments, ideally with minimal or perhaps even no direct human intervention for many tasks. It's where AI potentially moves from being a reactive tool that responds to your prompts.
To being a proactive partner that anticipates needs and takes initiative.
That's the vision, exactly. Think of an AI agent that's constantly monitoring your personal budget. It spots a transaction that looks potentially fraudulent based on your history and location. It then automatically researches the vendor online, decides to autonomously file a dispute with your credit card company, sends you a notification summarizing what it did and why, and maybe then even adjusts your projected savings goals based on the outcome, all without you explicitly asking it to perform each step.
So the software isn't just responding to a single prompt anymore. It's chaining multiple tasks together, learning from its successes or failures, and potentially adapting its goals over time.
Precisely. This requires a very deep integration of various AI capabilities, machine learning for prediction, LLMs for understanding and generation, natural language processing, sophisticated decision-making algorithms, all working together across entire software ecosystems.
This sounds like the ultimate long-term vision for personalization that tech companies have been talking about for years.
It certainly is framed that way. The long-term vision being discussed by software executives is definitely this shift toward highly personalized content, shopping experiences, maybe even life management, taking the form of these personalized assistants or agents that become intimately familiar with a user's unique interests, their purchasing history, their stated preferences, their calendar, everything.
The goal is creating large, autonomous systems that can act effectively on behalf of the user, whether that user is an individual consumer, a content creator trying to manage their online presence, or even an advertiser trying to optimize campaigns automatically.
That seems to be the direction of the ambition, yes.
But because this sounds like such a fundamental, almost science fiction level shift, there must be a necessary caveat here, especially for investors looking at this long-term horizon.
Absolutely. And this is the crucial hype cycle warning that executives were apparently very keen to stress at these conferences. Agentic AI is a massive research and development undertaking. It will require vast amounts of capital commitment, likely with very slow returns initially.
So don't expect profits soon.
Exactly. Despite the potentially significant long-term value proposition for consumers, creators, advertisers, investors should probably not expect significant profitability specifically from agentic AI systems in the next, say, 3 to 5 years.
Okay.
It promises, or at least envisions, redefining how software operates at a fundamental level, but the commercialization pathway looks long, complex, and expensive.
That's a really critical distinction to hold on to. Massive investment happening today for the underlying infrastructure, the compute. But the most exciting, truly autonomous features, this agentic AI vision, are still perhaps half a decade or more away from generating significant profit returns. So what does this all mean when we put it together? We've seen the incredible capital be committed, $500 billion being floated for just one project, Stargate, and we've outlined this clear strategic direction for innovation in 2025.
Yeah, I think we can synthesize the central narrative by looking at the confluence of those two major themes, the money and the technology trends. It feels like 2025 marks a definitive pivot point. The primary focus in AI seems to be shifting away from just pure model innovation
Towards infrastructure deployment and enterprise application.
Exactly. And this shift is validated, on one hand, by the staggering amount of capital being spent specifically on securing computing power. And on the other hand, it's being driven technologically by those 5 identified trends we discussed, the focus on enterprise reasoning, on auditability and interpretability, on robust evaluation, and then longer term on achieving autonomous action through agents.
So the bottom line, really, for any company operating in the tech sector today, or even any traditional company that's seriously adopting AI, is that guaranteed scalable access to compute power. The ability to actually run these massive models reliably at an uninterrupted, auditable scale. That has now become the single most important competitive differentiator in the industry.
It increasingly seems that way. In many cases, reliable access to compute might even trump having a slightly superior model if you can't deploy that model effectively at scale.
Compute access is the new strategic resource.
It appears to be. And it's being secured not just through complex legal contracts, but through these staggering commitments to global power grids, to physical real estate for data centers. We began this deep dive talking about the astounding scale. Reports of $300 billion deals, the need for 4.5 gigawatts of power, consuming as much electricity as 4 million homes.
Right.
And that this is now becoming the standard baseline cost of entry just to be a large-scale foundational AI player.
So let's leave you, our listener, with this final, maybe provocative thought to reflect on. If securing 4.5 gigawatts of continuous power is becoming the minimum barrier to entry today, just for the current generation of AI, what is the potential upper limit of computational and energy demands the industry will eventually require to fully realize the much more complex, multi-agent, autonomous, agentic AI future we talked about? And perhaps more importantly, what are the real-world implications of that ongoing $500 billion infrastructure race for global resource planning, for energy grids, for water usage, for land use in the decades to come?